our final question here. Express square root of 3 sine of 2x minus cos of x, cos of 2x in the form of r sine 2x plus alpha. So let's start with this r sine 2x plus alpha. So I'm going to rewrite that. Look at our formula sheet. It's going to be sine 2x cos alpha plus cos 2x sine of alpha. Expand our brackets, we get r sine 2x cos alpha plus r cos 2x sine of alpha. And on our left-hand side, we have square root of 3 sine 2x minus cos 2x. Equate our coefficients. So sine of 2x. So coefficient of that means that the square root of 3 has to equal r cos of alpha. Looking at our cos of 2x, now it's going to be -1 equals r sine of alpha. So equation 1, equation 2. 1 squared plus 2 squared. Now, you don't have to keep showing all the steps here. You can realize that it's just r squared equals, but r squared sine squared alpha plus r squared cos squared alpha. Hopefully it's quick anyway. -1 or squared plus root 3 or squared. So from here, you've got r squared sine squared alpha plus cos squared alpha equals 1 plus 3. So our r squared equals 4. Our r is 2. Oops. And that's because our identity here was equal to 1. Equation 2 divided by equation 1, sorry, because we want sine at the top. R sine alpha over r cos alpha equals -1 on root 3. So tan alpha equals -1 on root 3. Now thinking about what quadrant we're in. Our equation 1 was a square root of 3 equals r cos alpha. R is equal to 2. We have root 3 equals 2 cos alpha. So cos alpha equals root 3 on 2. So it's positive. From equation 2, we have -1 equals r sine of alpha. So -1 equals 2 sine of alpha. So -1 over 2 equals sine of alpha. So that's negative. And our tan alpha was also negative. So that means we have to be in our fourth quadrant. Hopefully that becomes quicker. I've put it in red because you can realize where you're at just looking at your values. So those coefficients in our original equation up here. Okay, as you do more, that should become easier to see. So now coming back to what we started with, we had that tan of alpha equals -1 on root 3. Our reference angle equals inverse tan of 1 on root 3, and that would be pi on 6. We're in our fourth quadrant though, so we want -pi on 6. Actually, I should write alpha equals -pi on 6. So therefore, I've run out of room, so I can put over here, square root of 3 sine of 2x minus cos of 2x has to be my r, which was 2, sine 2x plus my alpha, and my alpha was pi on 6. Sorry, my alpha was -pi on 6. And we are done.